between the two, and that's our growth or our decay factor and how we figure it out. Okay? But I really like today because today's all real world stuff. Okay? So, exponential growth occurs when a quantity increases by the same rate over time. So this is like when we're dealing with investments and stuff like that, when we're putting money in a bank and it keeps increasing our money. Okay? That's the best. Okay? So this little guy right here is our formula. Y equals A. And then inside here is our growth rate, our 1 plus R to the T power. So our A is our starting value. Okay. Our R is going to be our rate of change. And the T stands for time. So, original value of an investment is $1,400. Right? So, is that my starting value? Yep. We're going to write down our $1,400. Okay, now, it's increasing at 9%. Okay? 9% is what as a decimal? It's not 0.9, 0.09. Yep, because remember, so I have 9%, my decimal's right here, I have to move it 2 places. Okay, now, in here it says 1 plus our rate. So we've got to take 1 plus 0.09. What do I get? 1.09. So in my parentheses is 1.09. Okay. Now if I'm just writing the function, this is going to be to the T power or to the X power. I don't care which one you use. Okay. But in this case, what am I going to plug in for T? 25. So in order to do that, what you need to do, okay, because remember we always do exponents first, right? Yep, so we've got to go 1.09 to the 25th power. Okay, does anybody need help finding their exponent key? Okay, yours is going to look like that little upside down caret thing right there. Who else? Everybody else knows where their exponent key is? Alright, so you're going to hit enter. And then you have to multiply it by your starting value. So you're going to take that times 1,400 and hit enter. Okay. Then you've got to think, what am I talking about? In this case, I'm talking money, right? So if I'm talking money, I should be rounding to the nearest 100. Yeah, because that's going to be my cents, right? So in this case, I'm going to label it with money. I have $12,072.31. So that's pretty sweet. I took $1,400, put it in the bank, I let it sit there for 25 years, and that's a long time. But then all of a sudden, I've got over $12,000. It is sweet, isn't it? Okay, and that's kind of what when people are talking about investing their money and stuff like that, this is the kind of stuff that they're talking about. If you let it sit there long enough, it's going to grow. Okay, it's when you keep pulling out your investments after not very much time, it's not making as much money. Okay, so let's go to number 2. Okay, this time it says the cost of tuition. Okay, and this is the part that kind of sucks for you guys. Cost of tuition at college is $12,000. That's my starting. So we did end up with $12,000. Yep. Okay, so we've got $12,000, but the rate is increasing at 6%. Okay, so 6% of the decimal is 0.06, and remember And in 4 years, so what am I going to put in for my F? I'm going to put on 4. Okay? So now, I can do, remember you're doing this part first. So 1.06 to the 4th power. Don't forget to hit enter. Then times 12,000. And all of a sudden, 4 years later, how much is it going to cost for a year of tuition? $15,149.72.
They have the cents in there.
They would probably round it, but right, because it's just kind of a rough estimate right now. But in our case, we would. Okay. All right. So now we've got student athletes at a local high school, 300, and it increases at a rate of 8% per year. Okay. Starting value, 300. Growth rate, what goes in my parentheses? There you go, 1.08. And we're taking it to the power of 5. 1.08 to the 5th power times 300. All right, now are we talking money? No, now we're talking people. Okay, can I have 0.79 people? Well, no, I can't. Okay, so what am I going to put here? Yeah, we could go 441 what? Okay, people or athletes, either one. I would probably take either one. Student athletes, be more exact, yes. Can you use it for your starting value? 285. What are you using for your growth rate? Okay, which is, so in your parentheses, you're using 1.75. What are you guys using for your exponent? 23. Why did you choose 23?
2008 minus 1985 is 23.
Okay, 1985, yeah, totally. Yep, from 1985 to 2008, you've got 23 years. So
that's a lot of years.
it's a lot of years, and it's a really giant increase. So you've got 1.75 to the 23rd power, holy, times 285.
How many people live in Mayville?
Well, and they might not be talking about Mayville, North Dakota.
It says
Mayville.
How do
Yeah, it might not be Mayville,
million
North
people
Dakota.
fit into a town of Mayville? It shouldn't matter what town or
That's a lot of people in one.
New York has over 100 million people. Yeah, but this might not be Mayville, North Dakota.
They don't have 100 million people.
No.
They probably have like 23 million.
All right. Meanwhile, flip the page. All right. Exponential decay. And you need to pay a little bit closer attention to, because now we're decreasing. Okay. We still have A is still our starting value. R is still our rate, and T is still our time. Okay, the big difference between growth and decay is that now you're taking 1 minus your rate. Evan, get your head up. Okay, so what am I starting with? 1,300 people. So we've already got a little town. Maybe. Okay, now, my decay factor is what? 1%. What is that as a decimal? 0.01. So, or in your parentheses, you've got 1 minus 0.01. It's not negative. 1, not 0.01 minus 1. 1 minus 0.01. 0.99. Be careful. Okay, and then how many years are going by? 8 years. From 2000 to 2008, we've got 8 years. So now we've got 0.99 to the 8th power times 1300. And how many people are now there? 1,199 people. What's that? Well, if we rounded up, we could, yeah, but it's more fun to write 1199.
So how does the town only have 1,199 people, but 110 million cell phone subscribers?
We're not talking about Mayville. Sheesh.
You said it could be.
Hey, get over it.
Okay.
Okay, thank you.
Now.
All right, so now, this one is very realistic. Okay, you buy a car, and you buy a car for $18,000. Okay, it depreciates as soon as you drive it off that lot. It's going to start depreciating. Okay, and it's depreciating at 12%. So what am I putting in my parentheses? Point what? 0.88, because I'm taking 1 minus 0.12. And how long am I going to drive this car? 10 years. Not really. So 0.88 to the 10th power. Multiply it by your $18,000 that you paid for your car. So, Caitlin, you're very lucky if you only have to drive your car for 3 years, because most normal people have to drive it for a really long time because they don't have enough money to buy a new one every 3 years. I'm just saying. I'm just saying, let's not. Alright, so after 10 years, how much is my car worth? $5,013. And if you're lucky, somebody might give you 2 cents. Yes, sir.
Serious question right now. So if you drive, like you said, if you drive the car off a lot, it starts depreciating.
Mm-hmm.
So if you come back 10 minutes later,
A lot of times.
Cars go like down to $1,750.
It depends on what it is, but usually, yeah. They're not going to give you full price for it after you've signed on the dotted line. It depends. It depends. All right. I want you to do number 10. Because you made a bad investment. Your investment's losing some money. So what you got in your parentheses?
Oh,
Yeah, you gotta go here 1 minus 0.02. And so 0.98 to the 9th power times the $8,200 I invested. And now all of a sudden I made a bad investment. And now I only have $16,000 $68.36 and 73 cents. Mm-hmm. That's not how you do, because you didn't start with negative $8,200. Okay, it's just decreasing in value. Okay, so when it decreases in value, that's how we figure it out, is by taking that 1 minus how much it's decreasing in value by. Okay? All right? Make sense?